In part one of the Olympic medal count analysis, we introduced the data that we're using here on this very first tab. And we have all these countries and the number of medals that they won in 2012 in the Olympics, and then all this other demographic information about the countries. And we're trying to determine how good of an indicator each of these things is to the number of medals that the country won. So in other words, can I predict the number of medals that a country will win based on the country's population? Or can I predict the number of medals that a country won based on its GDP, which is what we're trying to determine right now on this tab right here. And what we did was we copied and pasted the data into this sheet, and then we created a scatter plot. That was where the last video left off. And one of the things that I want to just remind you of is on this scatter plot, let me resize it. We have GDP on the horizontal axis. That's like the input to our model. And then the output is the medal total. In other words, if you tell me a country's GDP, then I can use my model to predict the number of medals that they should win. And this may be, if GDP is a good indicator of how many medals a country might win, then my predictions will be very good. So the last thing we did was we inserted this trend line. And maybe it's worth just noticing that this trend line increases. And that should make some intuitive sense to us. Maybe as a country's GDP increases, we would expect that their medal count would also increase. And so that is what this trend line is showing. But we want to get a little more specific, a little more precision in our ability to predict, rather than just using qualitative indicators like the more GDP, the more medals. We want to put some numbers to this. So we're going to calculate the slope and the y-intercept of this line. And there are formulas in our spreadsheet to do this. And it's pretty simple. Again, I'm going to enter a formula here. So I'm going to start with the equal sign. And the formula that I want, you probably already guessed, is slope. And it gives us this little context information. Slope of line from linear regression of data. And that's what we're going to do. When I open the parentheses, I see that this function, the slope function, requires data for the y values and data for the x values. So let me start with my y values. That's medal count. And I'm just going to click on that very first value right there. Notice it's column C, row 3, which is why the C3 appeared here. And then I'm just going to hold down the Control and the Shift key and go down to the bottom of the data set. And notice here, the formula came with me so I can see what I'm working on. C3 to C56, and that is my Y data. And when I put a comma, you see that it's asking us for our X data. So I'm going to scroll to the top of my data set. I'm going to click on the very first data point. Control Shift down highlights the entire column. And then I can close my parentheses, and that's my formula right there. And I hit enter. And it gives me this value. And it's very precise, of course. It's a mathematical calculation, and it goes to, ever many decimal places that is. I'm going to use this key to just, decrease it until I have 3 significant digits. That's a good number without being too rigorous about my significant figures. I will just leave it at 3. And so that's the slope of this line. It's not your typical slope that we use in our linear equations, but it's a perfectly reasonable slope, 0.00717, so like 7 thousandths more or less. And we'll interpret that a little bit later. I do want to just think for a second about the units of this slope, though. Notice when you calculate the slope, or when you think about the slope of a line, a lot of times we think about rise over run. Okay, rise over run. And so imagine, what are the units of the rise in this case? It would be medal count. or the number of metals. And then the run would be GDP in billions of dollars. Okay, so my units are metals per $1 billion of GDP. And so those are the units of this slope. And again, down here in question number 4, it says, what does the slope of your regression line mean in this context? We're going to talk about that later. But just suffice it to say, we have a number for our slope, and our slope also has units. The other thing we can do is calculate our y-intercept from this data. And again, starting with the equal sign, and there is a function called intercept, and it gives you the y-intercept of the line derived via linear regression, which is what we're doing. Okay, so our intercept function also requires the y data and the x data. And here it says the y-intercept is somewhere around 8.25. And again, I'm just going to make my number a little more legible by throwing away some of that precision. 8.26. And the units of this y-intercept are whatever units we have on the y-axis, which is just metals. So that's 8.26 metals. And again, we will have a chance in question number 3 to talk about the context, the meaning of this y-intercept in this context. And that is the end of the second part.